Do you guys like rockets? Well, think about it. The space shuttle is so small, but when it's about to leave the Earth, right? It's attached to this giant thing. Why? Well, gravity is such a force, it doesn't want your rocket to leave. And there's so many chemicals that are needed to help get that small little space shuttle to leave Earth's gravitational pull. Now what's happening is, okay, there's a reaction and the rocket starts pushing downward when you see it just burning out and burning out. And as it's pushing down, there's an opposite reaction and the rocket goes up. That's an actual law in science. For every action, there's an equal and opposite reaction. Okay, so the boosters are shooting down and the rocket goes up. Now some of you are saying, well, how are we going to do this at home? But we can. And we're going to use chemicals. And we're going to make a reaction happen just like a real rocket ship. And all I need is a film canister. Today we have all digital cameras, but I'm sure if you look around your home, you'll find a film canister and construction paper. And if your parents ever have a problem sometimes with their bellies, Alka-Seltzer tablets. That's it. And I'm going to make this thing actually shoot up. Okay? So all I need, you could use any color. I'm actually going to use construction paper just because it's lighter in weight. And I'm going to make the body of my rocket. So I'm going to take this, because you could let the film canister just shoot up, but then it wouldn't look like a rocket. It just wouldn't look as cool. And now I'm going to wrap this around, just like this, and tape it down. And you know what I've created? I've created the body to my rocket. And you know, if you think it's too tall and you want to make it just a little shorter, you can trim it. Give your rocket a haircut or a paper cut. Now you need to make the cone. And it needs to be pointy because it has to cut through the air, because rockets have a couple of enemies, gravity and drag. So I'm going to take my cup and I'm going to make a circle. I'm going to just use the cup as an outline. Then I'm just going to cut out a piece of the pie. Okay. So I have a tracing of a circle and I cut out a piece, which I'll show you in a second. I'm going to cut this out all around. And I'm telling you now that the pointier your cone is, the easier it will be for it to be aerodynamic and cut through the air. Just cut out a piece of the pie, and now I have that. Now I'm going to take this, and I'm just going to wrap it, and I'm just going to make a cone big enough to fit the top of the body of my rocket. That's perfect. Tape it. And now, tape it down. If you wanted to add wings, you could add wings. If you wanted to use white paper and design the actual rocket, the USS Carmelo, you can do anything you want. But now, how do we get it to take off? Okay, so now it looks like a rocket, but how are we going to get it to fly? Well, I'm now going to flip it over. Like a real rocket, we have to load it up with chemicals. So what I'm going to do is take one tablet of Alka-Seltzer. Actually, I don't even need to use the whole tablet. Break it in half. And I'm going to fill up just the bottom with some water. And you know what's going to happen? When I drop this Alka-Seltzer tablet into the water, there's a chemical reaction and carbon dioxide is made. A gas is being made. Now, if I leave it open, the gas escapes. But if I close it, think about a balloon. The more gas, kaboom. It has to find a way out, high pressure. Well, if I close it, this is going to be making a gas, and let's see what happens. I drop it, it's in, and it's down. And 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, blast off. Did you see that? So much gas was being made and needed to find a way out. It pushed the gas downward and your rocket went upward. For every action, there's an equal and opposite reaction. Go make a rocket. What are you waiting for? Go.